Kia ora, Year 12. Here are the last two merit questions from the integration paper last year. So again, I'm going to pause the video and get you to have a go at them first. The first question, 3c, is a simple differential equation. We've got dy by dx is equal to this. And so we have to find the value of y when x is equal to pi, and we're given a fact at one point on the curve. Okay, so you don't need to take that the whole way through to get y equals blah, blah. You just need to do what it says and find the value of y when x is pi. So I think that's actually a pretty easy merit question, especially because I've chucked in the formula sheet that's going to help you with the trig function in there. The second one needs a little bit more thinking. It's a nice question. You've got the area under a curve and you're told that the curve is this, but you're not told the x values. So we have to find the shaded area. However, we are told the y values. So pause the video and have a go at those, and I will go through them. Okay, so let's first of all look at this trig one. We need to start any DE problem by checking that we've got our variables separated, and we don't. We've got x and y all mixed up here. So separating those, we get y dy is equal to sec squared 2x dx, and we're going to integrate both sides. So on the left-hand side, I'll get a half of y squared, and on the right-hand side, I'm integrating sec squared, so that has come from the tan function. So let's try tan of 2x. Now think about what happens when we differentiate that. Well, we're going to get sec squared of 2x times 2. So we have to undo the 2 by multiplying by a half. And I'm going to put my plus c on this side. It doesn't matter. You could put it either side. In this case, it really doesn't make that much difference in this example. Okay, now we're told that when x is 3 pi on 8, y is equal to 2. So I can substitute in 2, and I'll get a half of 4, 2 squared, is equal to a half of tan of 6 pi on 8. So 6 pi on 8 is 3 pi on 4. Let's just clean that up. That looks terrible. So tan of 3 pi on 4 plus c. Now tan of 3 pi on 4 is one that we should know. It's sitting over here, so there's 3 pi on 4. Tan of pi on 4 is 1. So tan of 3 pi on 4 is negative 1. So we've got 2 is equal to negative 1/2 plus c, because that's negative 1. That gives us c of 5 over 2. So we can put all of this back into here, and as I said, we don't need to go through and make y the subject, because all we have to do in this question is figure out what the value of y is when x is equal to pi. Now, they've given you a clue here as well. They've said values of y. I am going to just times everything through by 2 to save a bit of work. So we get y squared equals tan of 2x plus 5. And when x is equal to pi, we get y squared is equal to tan of 2 pi. That should be a plus 5 there, so plus 5. So y squared is equal to 5, giving me two solutions for y. Y is equal to either positive or negative root 5. There you go. And the schedule has that as a decimal, but I've just left that as an exact value. Either would be fine here. On to question 3D, sorry. Right, so 3D is one where we've got to do some integrating, but first we have to find our limits. So I think that probably the easiest way to go here is just to go straight to looking at, well, we know that y is equal to 2. So let's try and solve this and see if that's easy to do. It turns out it's very easy to do. So 2 is equal to 3x minus 2 over x plus 2. Multiplying through the x plus 2 gives me 2x plus 4 is equal to 3x minus 2. That gives us 6 is equal to x. So that's my first value here. I'm going to do that again now for y is equal to 1. 1 is equal to 3x minus 2 over x plus 2. So x plus 2 is equal to 3x minus 2. 4 is equal to 2x. X is equal to 2. That's that value there. All we have to do now is to do the integration and find the area. So the area will be the integral between 6 and 2 of 3x minus 2 over x plus 2 dx. Now I'm looking at the x plus 2, and I want to do something with the natural log function because I've got a quotient. Unfortunately, I've got this messy 3x minus 2 up here. So I have to rearrange this and take out some whole multiples of x plus 2. So we've got 3 lots of x plus 2, so I'm matching up the 3, but now I've got an extra plus 6 in here, so I need to take it out. I've added in 6, so I take it out, just like when we learned how to do completing the square a long, long time ago. So that gives us the integral between 6 and 2 of 3 minus 8 over x plus 2, which has suddenly got very easy to work out. It's going to be equal to what? Well, we've got 3x minus 8 times the natural log of x plus 2 evaluated at those limits. That gives me 18 minus 8 log 8 minus 6 plus 8 log 4. Right, just notice that the minus has turned into the plus. Cleaning that up a bit or throwing it into your calculator, we get 12 plus 8, and I'm going to combine these two, log of 4 over 8. Now I'm partly doing this for people in A level who have to be confident with exact values. If you're doing level 3 calc, it is totally fine at this point to just calculate this. So we get 12 plus 8 log of 1/2, or minus 8 log 2, or whatever, and when we get an exact value for that, it would be 6.455. So you'd get a full mark for that, and you'd also get a full mark for that. That's going to 3DP. Okay, so there you go. That's all the merit questions done. The excellence questions are coming up, but I need to go and do a couple of other jobs first. Thanks for watching.